Quantum processing is a significant pattern in software engineering. It's stunning to feel that everything began from watching the peculiar properties of light. There have been a few pioneers in quantum processing, the principal one being Richard Feynman. He clarified that quantum PCs are possible and that they are the eventual fate of computing. Quantum PCs have existed since root before you think. The main quantum calculation was completed in 1997, utilizing NMR on chloroform molecules. Nowadays, we've been attempting to slap the quantum popular expression on pretty much anything. And still, at the end of the day, there are as yet a couple of utilizations, in the interminable rundown of quantum advances, that are truly staggering. Improving cancer treatment. Disease is one of the main sources of death around the globe. Indeed, as per an ongoing study from the World Health Organization (WHO), respiratory malignancies alone guaranteed 1.7 million lives in 2016. In any case, if malignant growth is perceived at a beginning period, the odds of recuperation through treatment are a lot higher. There are numerous ways disease can be dealt with. One is to expel it by medical procedure, another is through radiotherapy. Beam enhancement is basic in radiotherapy, as it is imperative to ensure that the radiation harms as meager sound cells and tissues close to the malignancy area as could be expected under the circumstances. There have been numerous improvement techniques for radiotherapy in the past that utilization traditional PCs. In 2015, analysts at the Roswell Park Cancer Institute thought of another procedure that utilizes quantum tempering PCs, similar to the ones produced by D-Wave, to improve radiotherapy in a way that is 3 to multiple times quicker than that of a standard PC. 9. Better traffic flow. Huge numbers of us know about getting up ahead of schedule and embarking for work, just to discover an automobile overload looking out for the way. And afterward comes the unnerving inclination that you will be behind schedule for work. Google has been taking a shot at fixing this issue by observing traffic and proposing elective courses to its clients. Notwithstanding, Volkswagen is taking it to another level with their research. In a 2017 test, Volkswagen attempted to handle the issue of traffic, not through observing but instead by improving traffic stream itself. They utilized the quadratic unconstrained binary optimization (QUBO) strategy with quantum strengthening PCs to locate the ideal course for a select number of vehicles and potential courses in consideration. So far, they have tried this with 10,000 taxicabs in Beijing to show how their technique can improve traffic stream fundamentally quicker than an old-style PC. Be that as it may, numerous individuals are doubtful of Volkswagen's cases, since they utilized a D-Wave quantum tempering PC to do the preparing. Numerous researchers express that the quantum annealer's D-Wave makes don't offer a speedup as critical as Volkswagen claims. 8. Better mobile data coverage. We have all been in a spot where the versatile information gathering is unnecessarily awful, and we'd preferably simply utilize that moderate Wi-Fi hotspot in that close-by bistro. All things considered, it appears that an organization called Booz Allen Hamilton may very well have discovered the answer for the horrendous system inclusion issue, with the assistance of quantum PCs, of course. In a 2017 distribution, they proposed that ideal satellite inclusion is really difficult to make sense of. This is on the grounds that there are a great deal of conceivable arrangement blends, and it is extremely difficult to check every one of these mixes with old-style computers, the arrangement. They recommend that utilizing the QUBO procedure, as recently referenced, with the assistance of D-Wave's quantum tempering PCs, can help locate the ideal satellite inclusion position required. This would not imply that the satellites would have the option to cover all the awful gathering spots, yet the probability of having the option to discover a spot with better gathering can be expanded significantly. 7. Simulate molecules. Atom reproduction has been a significant field in science, as it causes us comprehend the structure of particles and how they cooperate with one another. Be that as it may, it likewise causes us find new molecules. Although old-style PCs these days might have the option to reenact these atomic elements, there is a constraint on the multifaceted nature of particles in a given reproduction. Quantum PCs can successfully break this obstruction. Up until this point, they've just been utilized to recreate little particles, similar to beryllium hydride, for instance. It probably won't appear a lot, yet that reality that it was mimicked by a 7-qubit chip shows that on the off chance that we had more qubits available to us, we may have the option to run very unpredictable subatomic simulations. This is on the grounds that the handling intensity of quantum PCs increments exponentially as the quantity of qubits increase. Other equipment, like D-Wave's quantum tempering PCs, has likewise been utilized by specialists to think of reproduction techniques that may be similarly as acceptable, if not quicker, than current strategies. 6. Break currently used cryptosystems other than RSA. A few of us may have known about the panic about quantum PCs having the option to break cryptosystems, for example, RSA or DSA. This is by all accounts valid for some cryptosystems, as they depend on prime numbers to create a key dependent on prime components. A calculation, called Shor's calculation, can be utilized by quantum PCs to locate the prime variables used to create the key, and they can do it considerably more efficiently. But shouldn't something be said about the different cryptosystems which don't depend on prime numbers to produce keys? There is another calculation called Grover's calculation which may be utilized to animal power a key quicker than a traditional PC. Be that as it may, this isn't as large of a speedup as Shor's calculation would offer, contrasted with a traditional PC quadratic versus exponential speedup. This would imply that we would require essentially quicker quantum PCs than the ones that as of now exist to try and endeavor to break these cryptosystems. Even with that, there are some cryptosystems that would be outlandish for quantum PCs to break. These cryptosystems are classified inside the field of post-quantum cryptography. Overall, however, no doubt in any event RSA, which is regularly utilized in advanced marks, would be out of date. 5. More human-like AI. Man-made reasoning is an amazingly drifting field in software engineering. Researchers have been attempting to make AI increasingly human-like through the methods for AI and neural systems. Appears to be frightening, however. Now add quantum PCs to the mixture, and it is taken to an entirely different level. Neural systems run on grid-based informational indexes, and the preparing done in neural systems is registered through the methods for lattice polynomial math. Nonetheless, quantum figuring itself on a very basic level works in such a nature, that grids are frequently used to characterize and decide the quantum conditions of qubits. So with that, any computational procedure done on the neural system would be like utilizing transformational quantum entryways on qubits. Consequently, quantum PCs appear as though the ideal fit for neural systems fused in AI. Not just that, however, quantum PCs can likewise help to altogether accelerate AI contrasted with a traditional PC. This is the reason Google has been putting resources into quantum PC research to improve Google AI by methods for quantum equipment. 4. Quantum cryptography. This is totally different from post-quantum cryptography, as it isn't intended to keep quantum PCs from breaking cryptosystems. However, it does that, in any case. This kind of cryptography utilizes the methods for quantum mechanics itself. Yet, how is it more flexible than different types of cryptography? Quantum cryptography fundamentally centers around the key dispersion part of a cryptosystem. Here, two sets of trapped qubits are utilized. One is sent to the beneficiary, while the sender keeps the other. Entrapped particles in a superposition, when estimated, influence the other qubit. Send a flood of these qubits, and you have a key usable for encryption. The best part about it is that listening stealthily is inconceivable, as the qubits can't be replicated. They can't be estimated, either, as there are techniques to decide if the qubit has been messed with before being gotten by the expected beneficiary. This makes it a hardy technique for cryptography, which is the reason researchers are as yet investigating this field. 3. Forecasting weather. We've all had that time where we've checked the climate conjecture, and it said that it would have been a magnificent, bright day. At that point, just minutes after the fact, it begins to pour, and you didn't bring your umbrella. All things considered, it appears quantum PCs may have an answer for that. In 2017, a Russian analyst distributed a paper about the chance of utilizing quantum PCs to foresee the climate more precisely than traditional PCs. There are a couple of restrictions with current PCs in foreseeing all the complicated changes in weather. This is on the grounds that a lot of information are included. However, quantum PCs appear to offer a major speedup contrasted with traditional methods on account of dynamic quantum clustering (DQC) system, which is professed to produce helpful datasets that old-style procedures cannot. Even along these lines, it must be noticed that not even quantum PCs can anticipate the climate with total precision, yet at any rate it will be more uncertain that we will lament not welcoming an umbrella on dubious bright days. 2 more efficient customized advertisements. We as a whole despise it when we look for an article, just to see it as covered with commercials. A large portion of it doesn't appear to be significant. Fortunately, Recruit Communications has discovered an answer for one of those 2 issues, the importance of ads. In their exploration, they clarified how quantum strengthening can be utilized to help organizations needing to publicize to arrive at a more extensive scope of individuals without spending excessively. The quantum tempering can be utilized to coordinate significant ads to clients so they're bound to click them. Point 1 Gaming with quantum computers. With all the speed-up quantum PCs offer in the processing field, one thing gamers may be interested about is whether they can be utilized to make a sweet gaming rig which can run games at bursting high frame rates. The appropriate response would be, sort of. At this point, the field of quantum PCs is still at its outset, and current equipment despite everything hasn't came to quantum matchless quality, which is when quantum equipment can process quicker than the present best PCs. However, the definition is as yet unclear. This is on the grounds that quantum PC calculations work uniquely in contrast to old-style ones. Indeed, even with that, quantum gaming despite everything is by all accounts possible. There have been a couple of games which have been created to use quantum PCs. One of them is called Quantum Battleships, which depends on the Battleships board game. Furthermore, Microsoft has been taking a shot at a programming language called Q-hash, which utilizes both traditional and quantum equipment to register. It is likewise fundamentally the same as C#, which would imply that it is entirely conceivable to create games utilizing Q-hash that exploit quantum equipment. Perhaps we'll have Call of Duty Q one day.